Right. Hello, everyone. This is take two of the Make a Game in 90 Minutes workshop. Um, so the idea is that in the next 90 minutes or less, you will learn how to make an endless runner with jumping and obstacles and death and, all that great stuff. And you only need a few things to get started. You'll need at least two sprites for run animation, a jump sprite, a ground sprite, a spike sprite, a relatively recent version of Unity, and Visual Studio. So assuming you have all that, let's go ahead and just import all of our sprites to get started. And let me shift click here to select all of them. And we're going to select no compression and point for the filter mode. And this just removes the anti-aliasing around sprites so that they won't look blurry if they're low res. Since I'm using pixel art, that's pretty important. So the first thing we'll do is drag in our ground sprite just right into the scene. Now this created a new game object with two components attached to it. So game objects are basically everything that you'll interact with in Unity. Anything that you see in game is going to be a game object. Anything that interacts with the game at all. And the components of a game object are what defines its behavior. Every game object has a transform component, which just gives it a position, rotation, and scale. And this ground object also has the sprite renderer component, which is what makes it visible. So pretty simple. So we do have a ground. If we go to our game view, we can see it there, but it's just one tile. So we're going to change the draw mode from simple to tiled. Ignore this warning. We're going to set the width to, 20. Yeah, that seems pretty good. Height to, 5. Let's drag it down a little bit. Yeah, looks good to me. Then we're going to add a box collider 2D. This is going to make it actually have collision with other game objects. We're going to set the size to the same as our tiling. So the X will be 20 and the height will be 5. Oh, and I should have mentioned this earlier. It's important that your ground sprite is 100 by 100 because that's basically one square unit in Unity. It doesn't actually have to be that size, but it just makes the numbers a lot easier to work with. So now we have our ground in our scene. We're just going to go to the layer and create a new one called ground. Then we'll go back to our ground object and set that to the layer. And that'll be important later so that our player can know when it's colliding with the ground. And speaking of our player, we can now add that. So we'll just drag in one of our sprites. And now we have a new game object. We'll call it player. Right now, it's not going to do anything because all it has is a sprite renderer. So let's give it a box collider 2D. This seems like a decent size for it. If you don't like the size of yours, you can either manually adjust the size here, or you can click this Edit Collider button and drag these handles on each of the edges to adjust the size. Next, we're going to add a rigid body 2D component. This is basically telling Unity that we want this object to be handled by Unity's physics system. Without the rigid body, it would just stay completely still. But now it has this, it should theoretically actually interact with the environment. So let's drag it up a little bit and play our game and see what happens. Might take a sec. So look at that, our player falls and collides with the ground since they both have box colliders. So that's pretty cool, but that doesn't make for a very exciting game. So preferably we would like this player to actually move forward, the run part of the endless runner. And to do that, we're going to click Add Component, New Script, and we'll just call this script player. Now, if you've never coded before, I know it might seem a little intimidating, but I promise we're going to be doing like very simple stuff for this project. And so even if you've never programmed in your life, it should be simple enough to follow along. And make sure you're using Visual Studio and that you're in the Unity solution. And if you need any help with setting that up, just let me know. So these are our two default methods, start and update. They do, as the comments suggest, start runs once at the beginning and update runs every frame. So let's make a new private rigid body 2D variable that we'll just call RB. By making it private, we're just saying that we won't be able to edit it in the Unity inspector. It'll just be handled internally in this script. Now we'll make a public float, and a float is basically just a whole number, and call it speed. In our start method, we'll say RB is equal to getComponent rigid body 2D, and that's just saying that when the game runs, the player script will search the player game object for a rigid body 2D component. It'll find one since we added it, and then it'll reference that, or RB will reference that component. Now in update, we're going to set RB.velocity to a new vector2. A vector basically just being like a set of numbers. So a vector2 just has an x and a y component. The x component is just going to be our speed, and the y component is just going to be rb.velocity.y, because we don't want to be directly modifying the y velocity. That'll be handled by Unity's internal gravity. And then the speed is just telling it to go in the positive x direction every frame. So already, if we go back to Unity, go into player and scroll down, we can see that under our player script, we can now set the speed variable. So let's just set it to 5, or you can set it to whatever you want. And click play and see what happens. So look at that, our player actually moves forward. But he just walks off the side of the screen and then presumably to his death off the edge there. Which, I mean, maybe it's a little funny, but that's not really what we're looking for in our game, so we'll have to make a couple adjustments. First, let's select this main camera object that's just in your scene by default, and let's drag that onto the player. What this does is makes the camera a child of the player game object, which means that whenever the player moves, the camera will move with it. So now if we run the game, yeah, we see that the camera actually moves with the player as we walk off to our death there. And I don't really like how the camera's positioned, so let's just move it to be kind of a nicer view. Yeah, based on the preview, I think that should be better. So that's pretty cool. Our player can walk forward, but it's not really an endless runner if, well, A, it's not endless, and B, we can't jump. So let's see if we can make our player able to jump. And just a word of warning, this is probably the most complicated thing we'll do in this entire project. And it's not that bad, trust me. So let's make a new public float and call it jump force. And basically what we want is the player to know when it's colliding with the ground. And when it's colliding with the ground, you're allowed to jump. And if you're not colliding with the ground, you're not allowed to jump. We can do like a rudimentary version of this by just putting in our update function or method if input dot get key down key code dot space. So if the player presses the space button, RBE.velocity equals a new vector 2. The x is just going to be speed again, and the y will be jump force. Copilot even figured that out. So basically, anytime we press the space key, it'll set the y velocity equal to jump force. So let's go into Unity and see what that looks like. If Unity would let me. Great. So we'll set the jump force to, I don't know, 5. And let's check it out. So if we press space, we can't actually jump. But if we keep pressing space, we can keep jumping, which isn't what we want to happen. So how can we tell if we're colliding with the ground? There are a few different ways to do this, but I'm going to show you what I personally think is the most reliable. It's not necessarily the easiest, but it's what I always use, and it's never done me wrong. So first, we're going to need a public layer mask that we'll just call ground layer. And if you remember earlier, when we set our ground game object to be part of the ground layer, that's what we're doing here, is we're just telling the player what it should be considering ground. Then we'll need a private bool, a bool being just a true or false value, called grounded, which will keep track of whether or not the player is touching the ground. Then we'll make a public transform called foot. So a transform is just the component that all game objects are required to have, and if you remember, it just keeps track of position, rotation, and scale. So in our update function, or method, sorry, we'll say grounded is equal to physics2d dot overlap circle. The point will just be foot dot position, so that's the point that we're checking. The radius we'll just set to some arbitrary small value like 0.1 f. The f is so that we know, or Unity knows, to process it as a float. And we'll be checking it against the ground layer. So what this is saying is if foot dot position, like if the point at foot dot position with a radius of 0.1 f is intersecting the ground layer, then we're grounded. Otherwise, we're not grounded, which means we're in the air. Then we'll say here, if input.getKeyDown, keycode.space, so if we press space, and we're touching the ground. So that way, if we try to press space, but we're not touching the ground, this won't activate. And let's give Unity a hot minute to process the code, because Unity's a great, okay. So we'll set the ground layer equal to ground. And we don't have a foot to pass into our transform. So let's right click on our player, click create empty, which just makes a new game object, call it foot. We should drag it down so that it's at the bottom of the player's hitbox. Then we'll pass in this foot for our foot transform. And let's press Control D to duplicate the ground, just to give ourselves a little more runway to experiment with. So if we press play now, I'm pressing space as hard as I can, but we're only able to jump when we're touching the ground, which is perfect. Now, I do think this jump seems a little bit floaty, and I don't know, it just feels not that exciting. So let's pause it. Let's go to our player. Right now we're in play mode, so any adjustments that we make will not be saved. This is a really important concept I probably should have mentioned earlier. Any changes you make in play mode are not saved when you exit play mode. For a change to be saved permanently, you need to make the change in edit mode. So we're in play mode, so we're just toying around. So I'm going to increase the gravity to like 2 and also increase the jump force to 10. So we doubled the gravity and the jump force. So let's see what our jump looks like now. I don't know about you, but to me, that feels like a way better jump. So we exited out of play mode, it reverted our changes, but I'm going to change it again so that we can keep it permanently. Great, so now we have a player that can walk and jump. But you probably noticed it's just a still image sliding around, which is kind of cringe. So we want our player to like actually have animations. So how can we do that? Well, we can go to Window, Animation, and Animation, and just drag this in up here. And it's going to prompt us to create a new animation clip. And I say that's a great idea. Let's call our clip Run. In this clip, I'll just drag in my 3 run sprites that I have. If you have more or less, let's A-OK. Okay. Now, let's make a new clip. We'll call it Jump. And we'll just drag in the 1 jump sprite. Perfect. Now if we go into Window, Animation, Animator, this might look a little overwhelming, but all it's doing is keeping track of all of our animation clips that we made in animation. So animation is to actually create the animation clips, and animator is to organize them and define the transitions between them. Let's go into parameters and create a new Boolean called grounded. So our animator has exactly 1 parameter, which is just whether or not the player is touching the ground. So our default animation is run. That seems about right. Let's make a transition from run to jump. We'll go into this transition and make it activate on the condition that grounded is false, right? If we're not touching the ground, then we should be playing the jump animation. That checks out. Let's go into the transition settings and disable exit time and set the transition duration to 0. This will just mean that the transition happens instantly. The reason it's on by default, like the reason it's not instant by default, is that for 3D animations, you generally want like a nice smooth transition, so it's not just instantly cutting. But with pixel art 2D animations like this, it'll look really gross with if we make the transition take any time. So that's why we set it to instant. Now we just have to make a transition from jump back to run. Same thing, no duration, no exit time. Let's add a condition that grounded is true, right? If we're touching the ground, then we'll just play the default run animation. And let's save it, and let's see how it looks. So our player is playing the jump animation, but it's not running. And I wonder why that is. Well, I'll tell you why. It's because this parameter in the animator is set to false, and nothing is ever setting it otherwise. So that's kind of an issue, because it just thinks that we're permanently midair. So how do we tell the animator whether or not we're touching the ground? Well, let's go back into our player script. Below RB, we'll make a new private animator that we'll call anim. We'll do the same thing in our start method. Just say anim equals getComponent animator. Then at the bottom of our update method, we'll say anim.setBool grounded. So it's setting the grounded parameter. And we'll just make that equal to the grounded bool in our script. So we already have the logic in the script to tell if we're touching the ground, and now we're just passing that information onto the animator. Now let's see how it looks. Okay, so it looks like our animations are changing, but it's running way too fast. So we'll set the speed to maybe 0.1 and give that another try. Great. It's looking like our player is actually moving now. Feels like a real game almost. But you may have noticed there's still one big issue where when we run out of ground, we just fall into the abyss forever. So next, we're going to add the endless part of our endless runner, which, it's pretty exciting, I know. So how can we do this? How can we make it so ground keeps spawning as the player progresses? Well, I'll tell you one thing. We can make a new C# script called ground spawner. Let's open it up eventually. Okay, so what do we want our ground spawner to do? I think the easiest way to visualize it is, it has to reload the domain, sorry. As the player is walking forward, it'll hit some kind of trigger that will then create the next ground, right? And then it'll just keep going. Every time it gets close to the end, it'll just keep hitting the trigger, which spawns another ground. And this ground spawner script is going to be that trigger. So what does it need? It needs access to a public game object called ground, because that's what it's going to be spawning, right? It needs to know what to be spawning. So we'll give it a game object to spawn. We actually don't care about any of this default method crap. We're going to be using one of Unity's built-in methods called onTriggerEnter 2D. Make sure you're using 2D, please. That, by default, takes a collider 2D called collision. And so this method is triggered anytime our ground spawner collides with a trigger, or anytime another object collides with the ground spawner trigger. And the collision is just going to be whatever it's colliding with. So we want to know that we're colliding with the player. So we'll say if collision.tag is player, case sensitive. So if we're colliding with the player, what do we want to do? Well, first we need to move this trigger forward by the length of the ground. And if you remember earlier, we set our length to 20. If you set yours to something else, then just put whatever you put for 20 here. So how do we move it 20 units forward? We'll use a built-in method called transform.translate, which takes a vector 3 or a vector 2. Since we're in 2D, we'll use a vector 2. We don't really care about the z component. So we'll move it by a new vector 2. The x will be 20, since that's the length of our ground, and the y will be 0. So great, every time the player touches the trigger, it moves 20 units forward. But that's all it does, which is kind of useless. We need to actually spawn ground. So we'll say that it instantiates, which is just a fancy word for spawn or create. We'll instantiate the ground game object at transform.position, which just means the position of this object, this trigger, and quaternion.identity, which just means that it'll have a default rotation. It's not going to have any kind of crazy whatever rotation. So let's go back into Unity eventually. Okay, so let's create a new game object called ground spawner. we want it to be at the position of like this ground here. So the easiest way is to just make it a child of that ground, set its position to 0. So basically when something is a child of another game object, its transform is local. So it's relative to its parent. So relative to its parent, it's just going to be 0. Then we'll drag it out here to make it not a child anymore. Then let's add our ground spawner script. And okay, here's an issue. What do we want to spawn for our ground? Well, I'll tell you what. We're going to take this ground here, and we're going to drag it right into our assets folder. This creates a prefab of ground, which is basically just an instance of the game object that's saved in our assets instead of being active in the game. So this way, we have like a perfect reserved copy. It's basically like the patient 0 that all the other grounds are going to be modeled after. So let's say we want to change something about the ground. We want to change its sprite or whatever. Well, we can just edit our prefab, and then all of the newly instantiated instances of ground will also have the changed sprite. So in our ground spawner, we'll drag in this prefab, and that's pretty cool. The code should work now, but it doesn't have a trigger, so it won't know when it's colliding with player. So let's add a new box collider 2D. We'll check the is trigger box so that the player doesn't actually collide with it like a wall. Let's increase this Y size by, I don't know, a lot, by just dragging on the Y. 20 seems fine. And then let's move the X offset to be more to the left. So that way, when the player is moving along, hits the trigger here, it'll spawn the ground over here off camera, so you won't see the ground being spawned in. It just looks a little nicer that way. And finally, this is a pretty important part. Go into our player and set the tag to player. We forgot to do that earlier. Now, if we give it a go, let's see what happens. So our player's walking along, and we just hit the ground trigger, and look at that, it's spawning in new grounds. So if we go into our scene view and zoom out, we can see that as the player walks, it keeps hitting the trigger and keeps spawning in new grounds in front of it. So now our endless runner is in fact endless. We can even jump. Now we just have a more philosophical issue of the game not being fun. I mean, really, what are we here for? So, and we also have a more practical issue of it's going to keep spawning grounds forever, which is known in the industry as a memory leak, right? If someone like left this game running overnight, eventually it would spawn so many grounds that would all be stored in like a cache somewhere that things would start breaking. So we're going to make sure that our grounds are being deleted after they're not needed. We'll say that instead of just instantiating the grounds, we'll say that game object go equals this instantiation. This way, we're basically just storing the object that we create in the script so we can modify it. Then we'll call the default method destroy on go with a delay of like, I don't know, 15 seconds. Yeah, sounds good. Save that. And yeah, now as we move along, it will be deleting the grounds behind the player and then spawning the new ones in front of the player. So there will always be at most, like, I don't know, 10 or 20 ground objects instead of infinite. So that's pretty cool. Now, what do we want? We want some kind of obstacle for the player. Some kind of spike, maybe. And I'm going to tell you something that might blow your mind. this ground spawner, all the logic we just did, will work just as well for spawning spikes as spawning ground. So we can actually just reuse that same script. So here's what we'll do. Let's duplicate the ground spawner with Control E, call it spike spawner. We don't want it to be spawning ground, so we're going to have to make a spike object for it to be spawning instead. So let's drag in our spike sprite. Looking pretty tiny there, so we'll maybe up the scale to like, well, that looks kind of big. Maybe 3 by 3. I'll tell you what, 2.4 by 2.4. That seems okay. Now, what does this spike need? Well, it needs a box collider. We'll set that to be a trigger. And let's make a new tag called spike. And then give our spike object that tag. So pretty cool. We have a spike now. And same deal, we'll drag that into assets. Now it's a prefab. And just as a little bonus, our folder is looking kind of hairy right now. So we're going to be nice. We're going to make some folders. Make one called scripts. Make one called sprites. Make one called prefabs. Let's drag all of our sprites into sprites. We'll put the animators in there too. Put our scripts in scripts. Prefabs and prefabs. Oh. There, that's nicer, huh? A little organization is always a good idea. Anyway, we'll go to our prefabs folder. Let's go to our spike spawner. Or, sorry, that's just a spike, not the spike spawner. We'll delete that. Spike spawner, give it the spike. It's going to be spawning the spikes at its position, which right now is like 3 meters into the floor. So we'll move it up here so that it spawns them like on top of the ground instead of in the ground. Okay, let's give it a play and see what happens. So our player's walking. Okay, what the hell? Okay. Seems like we perhaps tripped on nothing and fell over, which I don't know about you, but I normally don't want that to be happening in my endless runner. I'll tell you what, we'll take this ground, take its X position, paste that into this one, and then just do a little minus 20. Okay, this way the grounds should be exactly 20 meters apart, which, you know, in an ideal world, will make our player not trip on nothing. That's just weird Unity being annoying because, yeah, like look at that. That's weird. We don't want that happening. But the good news is that our spikes are indeed spawning. And it looks like our player is not tripping on nothing anymore. So we can jump over the spikes. And we almost have like a functional game now, which is kind of cool. And you can see in our scene view that new grounds and spikes are being created and being deleted. So we don't have like infinite spawning. So now we have a few issues. One, we want the player to not do that. That's a great demonstration. 2, we want the player to actually be colliding with spikes instead of just phasing through them. And 3, we want the spikes to be spawning at like some kind of interval. So it's not just, I don't know, not so boring. Like the spikes right now are very predictable. So, okay, issue 1, let's have the player not trip on nothing. Let's go to our player, and for the edge radius in our box collider, we'll set it to like 0.1. You can see that puts kind of like a rounded square around the thing. And then we'll just decrease the scale a little bit. So like 1.8 might be fine. Yeah, that looks okay. Then we'll go into our assets. Let's create a new 2D physics material 2D. We'll call it no friction. I'll tell you why we call it that, because we're just going to set the friction to 0. Then we'll go to our player, and in our box collider, we'll drag in this no friction material. We'll also drag it into the rigid body. Now, I pray to everything that is holy that the player does not trip over nothing. Let's see. So far so good. Let's increase the player's speed. Let's make it like 20. Whoa, we're zooming. And we're still not tripping over anything, which is music to my ears. Okay, sorry about that weird Unity physics stuff. That's the issue with using the built-in physics system, is that there are always going to be weird quirks like that. I promise you, it is still easier to work with those weird quirks than trying to make a physics system by yourself. I mean, you're welcome to try, but it's a lot of heartache for not a lot of advantages. Anyway, good. Our player walks forward. We're spawning spikes. We're not tripping. Sounds good. So, also, I'm going to move the spike spawner up a tiny bit. It looks like they were slightly on the floor. Okay. Let's go back into our ground spawner script. Yeah, you can reload, whatever. So, right now, an error occurred. Oh, that's because we moved it when we organized our folders. So we'll just search ground spawner. Here we go. Okay, we're back. So how do we make it so that the spikes spawn at like random intervals and not 20 units every single time? Well, I'll give you a hint. We literally say in the code to spawn it at 20 units every single time, which is great for the ground, but not great for the spikes. So what can we do about that? Well, let's add a new public float called randomization. And then we'll say that it's 20 times mathf dot random, or not mathf dot random dot range. 1 minus randomization will be our minimum, and 1 plus randomization will be our maximum. So let's just think about this for a second. If randomization is 0, it'll just be a random.range from 1 to 1, which is always going to be 1. So it'll always be 20 times 1, which will just always be 20. So with 0 randomization, it's always 20. That makes sense. If randomization is like 1, then it'll be a range from 0 to 2, which means that it'll spawn anywhere from 0 to 40 units away, which is quite random. Let's save that script and go back into Unity. In our ground spawner, we don't want any randomization since we're relying on the ground to be precisely 20 units every time. But in our spike spawner, we can set that randomization to like, I don't know, 0.5 and just play that and see how it looks. So we're walking along. We're spawning ground and spikes. The spike is on top of the ground. Alright, that's pretty cool. The spikes are at random intervals now. I mean, I really have no idea when the next spike is going to spawn. That's pretty sick. So now we just have the issue of making the player actually like die when we touch the spikes. And this, well, I'll tell you one thing. We could just make it so we restart the level as soon as we touch a spike. And that would work fine. It would be completely functional. But it wouldn't be very exciting. And what's the point in making a game if you don't have any excitement. So instead, we're going to play a little particle animation when we die, and then restart the scene. Okay, so hang with me here. I know it might be a little bit crazy, a little bit wild, but let's see what we can do. Let's create an effect, create a particle system as a child of our player. Right now, it looks really ugly, like really ugly. So we can do a few things. And I know, look at all of these parameters. I know it's scary, I know. But first, let's go into the renderer and take the order in layer and set that to 1. So it'll be spawning above the player instead of behind the player. I think it just looks a little nicer that way. Then for the material, instead of the default particle, we'll do the default sprite. So now they're squares instead of weird little orbs. Then in shape, actually the shape is fine. Don't worry about that. But I'll tell you one thing. We probably don't want it to loop. We probably do want it to play on awake. Where is that? That's here. That's on by default. That's good. I guess we'll leave it looping for now, just so we can see what it looks like as we edit it. Let's make it smaller, like 0.5. Yeah, that's probably good. Start color, we'll make it like red, pretty violent. You can really go hog wild here. You can do like whatever you want. Play around with these parameters. Control Z is your friend if you mess something up. Really the most important thing is that we go into a mission. Let's set that rate over time to 0. We don't want it to be like a slow trickle. Instead, we're going to add a burst. And here's where we can turn off looping. So let's play it. Yeah, that's a pretty gnarly burst of particles. That really looks like I touched a spike and died. But it goes a little bit slowly for my taste, so we'll increase the simulation speed to like 2. Yeah, that looks a little better. Maybe we can even do 3. Yeah. Now that's starting to look pretty cool. But I don't like how the particles just go out and then like despawn. Like that looks weird. So let's give it the property of color over lifetime and expand that. And all we're going to say is at the beginning, the alpha will be full. So there'll be full transparency. But at the end, oops, I didn't mean to create a new thing. At the end, oh brother, that alpha is going to be 0. So they'll have a slow fade from full transparency to, like fully visible to transparent. Yeah, that looks better. It looks less like they're just snapping out of reality. But I don't like how uniform it all is. So let's go into the start lifetime and make it at random between like 3 and 5. Yeah, that seems fine. Yeah, now it's a little more random. We can even do 2 and 5. Yeah, I think that looks pretty good for all intents and purposes. We're not trying to make the Mona Lisa here. We're just trying to make a little particle effect. So let's disable it so that it doesn't play as soon as our game starts. And we'll just keep that in our back pocket for now. Let's open up our player scripts. Oh, we moved it, so we have to go into our solution, search player, player.cs. Perfect. Okay. What do we want to happen? We want an onTriggerEnter 2D method. We're going to say if collision dot tag equals spike. So if we're colliding with a spike, what do we want to happen? Well, we want to activate our cool particle system. So let's make a public game object. We'll just call it particle system, really creative. Why is it giving me a warning? Oh, I guess we won't call it particle system because that's used somewhere else in Unity's system. We'll just call it PS. That should be fun. So when we touch the spike, we'll do PS dot set active true. Okay. Let's go back into Unity. Eventually. Okay. We'll go into player. We'll slot in our particle system for PS. Perf. We'll go into prefabs, spike, and look at that. It already has the spike tag that I said earlier. I actually completely forgot about that. Great, so let's give it a play and see what happens. So our player's walking, just chilling. Oh no, looks like there's a spike. Oh, whoa, look at that. All right, we hit the spike and we just explode into a million red pieces. That's pretty cool, but I didn't like how the player kept walking when we got hit. So how about we also set speed to 0 when we touch a spike. And then we want to restart the scene like a second or two after we hit a spike, right? So we can see that we died, we process what happened, and then restart the level. To do that, we're going to use Unity's Scene Manager. So we're going to tell it that. We're going to say using Unity Engine done scene management. Cool. Now, when we collide with a spike, we're going to invoke a method. The method will be called, I don't know, restart scene. We'll invoke it in like 2 seconds. So when we collide with a spike, it'll be invoking this restart scene method in 2 seconds. But there is no restart scene method, so let's make one. We'll make a private void restart scene. We won't take any parameters. We'll just say scene manager dot load scene, and then what scene are we loading? Well, the current scene. So scene manager dot get active scene. So dot name. Okay, great. So in restart scene, it'll get the current scene's name and then load that scene, which is basically just a verbose way of saying restart the scene. Let's go back into Unity and see what happens. So we're walking, we're jumping, we're loving life. I see a spike. Let's jump over this first one. Oh, looks like I failed to jump over it, but I did have the particle animation and I did restart. So look, I'm not going to say it's the prettiest animation I've ever created in my life, but it gets the point across, okay? But have you noticed, it seems like we're colliding with the spike when we really shouldn't be, right? Like, come on, I definitely jumped over that. And if we look at our hitboxes, it looks pretty accurate. But I'll tell you a trick, and this might ruin your enjoyment of every video game you ever play. But we're going to set the hitbox to be like quite a bit smaller than it looks like it should be. Like, we'll set the X scale to 1. Sounds good. Let's go to our spike. Let's set the hitbox to like something like that. So it's really only the center of the spike with any collision. Now if we play, we should hopefully find that it feels a lot more fair. Like, oftentimes having fair hitboxes feels unfair. So for it to feel fair, you have to have pretty lenient hitboxes. So, here comes a spike. Let's jump over it. Wow, perfect. Pretty incredible. Another spike. Let's jump over it. I mean, at this point, we already have a game. Like, that's pretty cool. Let's hit this one. Oh, no, I died. Oh, shucks. Okay, great. I like what I see. So, at this point, we already have a functional game. Like, there's no denying that. Now, we're just going to add stuff to make it a fun game instead of merely functional. Okay. So, I think what this game could really use is like a score indicator. Wouldn't that be cool? So you knew exactly what you're doing. So let's do that. Well, actually, first, I'm going to go into our main camera and change the background color to be like a nice dark gray. Could even make it like a little purpley. Oh, look at that. This feels way cuter than the ugly default blue backgrounds, okay? I'm just putting that out there. So how do we make a score? Well, first we're going to need text to actually show the score, right? So let's create a new UI element. We'll make a text element. And this can say, oh, we have to import this stuff. Well, let's do it. Basically, the reason Unity uses this TextMesh Pro thing is because their default text system is so bad that this TextMesh Pro asset, like third-party asset, got so popular that it basically became the industry standard. And so Unity just bought it and made it the new default and calls all their default text stuff deprecated, which is pretty funny. So here's our text. It says new text. Let's make it say like 0. And let's move it up into the corner of our canvas. Our canvas is this huge white rectangle. I don't know why it's like that. It's just the way of the world. So great, now we can see our hypothetical score. Make it a little bigger maybe. Let's increase that font size, dragging it out. Cool. So what do we want to happen? We want the text to actually reflect our score and increase over time. So let's go into our player script. To edit a UI element, well, actually, to edit a TextMesh Pro element, we're going to have to say using TM Pro. Then let's make a new public TextMesh Pro UGUI. We'll just call it score text. Then we'll make a public float that we'll call score. So we'll keep track of the score, and then we'll set the score text to be equal to the score. Sounds good. So in our update method, we will say score plus equals. So we're just increasing the score by some amount. That amount is going to be speed times time dot delta time. Okay, why are we doing this? It seems weird. Well, I'll tell you one thing. If we ever want to increase our speed, then the score will then also increase faster, right? This way, the score is a measure of our distance traveled and not just our time spent alive, which I think makes more sense. And okay, but why time dot delta time? Well, if you're really observant, you may notice that update is called once per frame. Well, what is once per frame? It's not constant, right? What if someone is running their our game on their mom's MacBook from 2008 and it's running at 10 FPS? Well, then this will be called 10 times per second. And then someone else is running it on their $5,000 framework. Well, it'll be at 500 FPS or something, and this will be called 500 times per frame. So it can be a huge difference in frame rates. And this time.delta time just adjusts the frame rate, adjusts for the frame rate. Time.delta time is a measure of the amount of time in seconds since the last frame. So this way, no matter what frame rate you're running the game at, the score will be increased by the same amount. Okay, sounds good. And then we want our score text dot text. So we're setting the text of our score text to be equal to score. But if we do this, it's going to give us an error, a little red squiggly. Why is it doing that? Well, it's because we're trying to set a string, which is like a text value, to score, which is a float, which is a number. And those are incongruent. And if you've programmed in Python or something with typecasting, it would just figure this out by default. It would just know, oh, you're just trying to say take the number as a string. but C# is not so kind, so we're just going to have to tell it that we mean it as a string. The easiest way is just put like an empty string plus score. So, okay, now it's all good. Now we know that we mean this as a string. Okay, sounds great. Let's go back into Unity. Let's go into our player. Let's drag our text into the score text field. Oh, I just realized that the score variable probably shouldn't have been public. It doesn't really matter. Let's play, see what happens. Okay, so our score is indeed increasing. And if we like increase our speed, well, let me get over this spike. Like, if we increase our speed to like 10, then the score increases faster. But you may notice the score is like horrifically ugly. So let's fix that. We'll go back into Visual Studio. Okay. Let's do two things. One, let's make the score like a multiple of 10, because that just feels, I don't know, feels nicer that way. And two, let's remove all those nasty decimals. So this is going to be a little bit of a cerebral exercise, but let's see. We will instead of just directly passing in our score float, we'll say mathf.round to int score. Whoops. And then we'll say times 10. Let's see how that looks. Eventually. Okay, in my opinion, that looks much nicer. Feels like a real game. And for our final touch, let's just make the speed increase over time. So we'll make a new public float called increase speed by, and we'll just say every frame speed plus equals increase speed by times time by delta time. Same deal, we're just adjusting for the variable frame rate. What should we make our speed increase by? How about like 1 per second? That seems pretty fair. So we'll keep getting faster over time. The game will get harder. Okay. We are getting faster. The score's going up faster. Oh, it's exhilarating. Whew. Oh, and I died. Oh well. Oh, and I guess when we die, we should also set speed increase by also 0. Alright, that was pretty exciting. I think maybe all we should do is just make it not get so fast so quickly. Instead of 1, we'll say like 0.5. Let's give that a play. See what happens. Okay, we're walking, we're chilling, jump over a spike. Wow, all right. So with, over the course of the past hour, or however long it's been, whoa, what the heck? Oh my gosh. We tripped over nothing. All right. Let's go into our rigid body constraints and freeze the rotation, the Z rotation. So it's not like falling over onto the ground. That was pretty ugly. Just Unity things. Anyway, as I was saying, we have a functional game now. I mean, we can jump over spikes even. We have a score, it gets harder over time. It doesn't look half bad. It's quite like a mental, I mean, it's quite exhilarating play too. And with that, you've now made a game, which is more than like 90% of indie devs ever will. So congratulations, give yourself a big pat on the back. And just imagine like things you could add. Like imagine making a new version of the spike spawner that spawned some kind of power up that when you interacted with it, it lowered your speed slightly. Or I don't know, you could add a health system where the player has to hit 3 different spikes before you die. Or you could add new obstacles that spawn in the air instead of on the ground. I mean, there's a million things you could do to add to this game just using the stuff that you've learned in this video. So you have the foundation, um, and really the world's your oyster. So I hope you found this video helpful. Um, I hope that you enjoyed making your first game, and I hope that this is the beginning of a long and fruitful journey for you. So, great. Thank you so much for watching, and yeah, have a great day, and don't trip over nothing, please.